Welcome to Ohio Energy Project Virtual Lesson 2, Lighting. So if you'd like to follow along, this is page 21 of your student guide, which can be found at ohioenergy.org/students and families. So a little background on lighting. We use it every day in our homes, at school, everywhere. So it accounts for about 5% of our home energy use and 11% of our home electricity bill. So it's a decent bit of our energy that we use. So it's a very important thing to keep in mind about conservation and saving energy. So we have three types of light bulbs. There's the incandescent light, which only about 10% of the energy that the bulb uses will actually go into producing light. So it's not very efficient. We don't want to be using this as much anymore. Then we have the CFL, much more efficient. It uses 75% less energy than the incandescent. The only concern is that it has mercury in it, and mercury is not great for the environment or for our bodies, so that is not the greatest. So the best solution is the LED, which stands for light emitting diode. It uses the least heat and is the most efficient. So to carry our experiment, we're going to need a few things. We'll need the bulbs, we'll need the lamp bases, which should all be the same, and then we'll need 3 thermometers to measure the temperature change. We'll also need a ruler for creating the line graph, which we won't be doing today, so I'll set it aside. You'll also want a timer of some sort, so I'll be using a phone, but if you don't have a phone, any kind of timer or your parents' phone can work just as well. So what we're going to do is place the thermometers under each lamp. So we want to make sure all of the settings are the same to make sure it's a good experiment. So we want the same height between the lamps and the same distance and everything. So we're going to turn on the lamps and get a time 0 reading. We'll write this down on the data sheet on page 22 of the student guide. And so I already wrote these down, but the starting temperatures are 67.4, 68.4, and 68.8 degrees Fahrenheit. So they're not the same at the beginning, but that's okay because we want to know about the temperature change. So I will only be doing 5 minutes today, but if you were to do it, you do a 10-minute change. So I'm going to start the experiment. We'll turn the lamps on, and then we'll come back once the data is recorded. Now that we finished our 5-minute trial for the experiment, we've got all our data written on page 22 of the student guide. So as you can see, the initial temperature for the incandescent bulb was 67.4, the initial for the CFL was 68.4, and the LED was 68.8. At the end, the incandescent was 77.1, the CFL was 71.1, and the LED was 69.7. So as you can see, the change in temperature over 5 minutes was 9.7 degrees Fahrenheit. So this is quite an increase compared to the CFL, which only increased by 2.7 degrees, which is about a third of the incandescent bulb change. And the LED only changed temperature by 0.9 degrees, which is also about a third of the CFL. So what we can gather from this is that the LED produces the least amount of heat, followed by the CFL and then the IA, or incandescent bulb. So now let's move on to the lighting investigation results on page 24 of your student guide. So question 1, do your results support your hypothesis? Explain. So our hypothesis was that the LED would produce the least amount of temperature change, followed by the CFL and the incandescent. Our results do support this, showing that the greatest change was the incandescent and the lowest was the LED. Number 2, what characteristics do the light bulbs have in common? So all of the light bulbs produce light and they produce heat. Heat is another form of energy that is produced, so it is inevitable to be produced. Number 3, how do the light bulbs differ? So as we talked about, the incandescent produces only about 10% of light compared to its total energy production. And then the CFL differs because it is contains mercury. Number 4, which light bulb is coolest in temperature when in use? So that would be the LED. Again, based on our data, the temperature change is the least, so it will be the lowest in temperature when used. Number 5, which bulb is truly a heat bulb, not a light bulb? This would be the incandescent bulb because it produces significantly more heat compared to the other bulbs. So it is producing a lot more heat than it is light, so it would be a heat bulb. Number 6, what variables remain controlled? The variables that are controlled are the same light bulb, light bases, the same distance from the light to the thermometer, and the same type of thermometer. We want to control the variables so that the only thing that changes is the temperature. That way we know that it's a good experiment. Number 7, what was your independent variable? So the independent variable is the one thing that changes, which would be the type of light bulb, incandescent, CFL, or LED. What was the dependent variable? That was what changed. So what happens when we change the light bulb, and how do we measure that? So this would have been the temperature. So that shows you that based on the independent variable, which is the light bulb, the change in temperature shows that there is a difference between them. Now that we've done the experiment to see which is the least to most efficient light bulb, there are a few ways that you can save energy at home. So first, you can switch from incandescent bulbs to CFLs or preferably LEDs. This will save you energy while giving you the same amount of light. You can also turn off lights when you're not in the room. It's a great way to save a few dollars on your bill and just not waste, because wasting is bad. You can also use natural lighting, so open blinds, curtains, anytime during the day. It'll give you a great free source of light. So I hope you enjoyed this experiment. Please check out additional videos on our website, which is listed here, for other exciting experiments offered by Ohio Energy Project. And thank you for watching.